Welcome to Frost and Sullivan's Growth Podcast. In each episode, we take a deeper look at transformative shifts shaping global ecosystems, from industry megatrends and technology innovation to evolving customer expectations. Today, we're exploring how the explosion of digital data is reshaping data center cooling and infrastructure design, and what it means for organizations preparing for the next wave of AI-driven computing. To begin, we're seeing massive growth in digital data generation. What's driving this surge?
The growth is coming from several directions. The expansion of the internet, mobile devices, cloud computing, and artificial intelligence is dramatically increasing the volume of global data. To support this growth, organizations are rapidly expanding data center infrastructure around the world.
And as infrastructure expands, the challenge of managing heat becomes more significant.
Exactly. As computing power increases, servers generate much more heat. High-performance processors and dense racks require more advanced cooling solutions. Efficient thermal management is now a critical factor in ensuring performance, reliability, and uptime in modern data centers.
So traditional air-based cooling approaches are starting to reach their limits.
Yes, particularly in high-density environments. AI workloads and hyperscale deployments are pushing rack densities beyond what conventional air cooling can efficiently handle. This is why operators are exploring advanced cooling methods such as liquid cooling, direct-to-chip systems, and immersion technologies.
Beyond hardware, digital management tools are also becoming important.
Absolutely. When advanced cooling technologies are combined with sensors, AI-driven controls, and digital infrastructure management platforms, operators gain real-time visibility into thermal conditions. This helps optimize energy consumption and maintain system reliability.
Let's talk about the broader forces shaping this transformation. What megatrends are influencing data center design?
AI expansion, hyperscale data center growth, and data localization regulations are accelerating global construction of new facilities. At the same time, higher rack densities are increasing heat loads and energy demand, which is pushing operators toward efficient, low-water cooling systems integrated with smart building technologies.
And technology innovation is playing a major role here as well.
Definitely. Liquid cooling and direct-to-chip systems are becoming essential for high-density computing environments. Advanced sensors, AI-driven controls, and digital twins are enabling real-time monitoring and predictive optimization of cooling systems.
We're also seeing greater collaboration across industries.
Yes, the ecosystem is becoming more interconnected. Data center operators, energy providers, IT equipment manufacturers, and automation specialists are working together to deliver integrated infrastructure solutions. This collaboration supports scalable, energy-efficient facilities aligned with rising computing demand and decarbonization goals.
How do regional dynamics influence cooling strategies, and what about Asia Pacific? In the Americas, hyperscale AI clusters and high-density colocation facilities are driving rapid adoption of liquid and hybrid cooling technologies. Infrastructure upgrades and power agreements are supporting that growth. In Asia Pacific, sovereign cloud policies and capacity constraints in major cities are pushing development into secondary hubs. These locations often require high-efficiency cooling designs that can operate effectively in warmer climates. Europe and the Middle East also face unique regulatory pressures. And Latin America?
Yes, strict carbon policies and limited grid capacity are encouraging operators to adopt energy-efficient cooling systems and reduce reliance on high refrigerant technologies. New cloud regions and high-temperature climates are driving demand for air economization, indirect evaporative cooling, and modular chiller systems that can support reliable operations.
Let's shift to opportunities. What new business models are emerging?
One major opportunity is the development of AI thermal platforms. Instead of standalone cooling systems, providers are creating integrated architectures where cooling, power systems, sensors, and workload signals operate together. Many providers are collaborating with major chip makers and IT companies such as NVIDIA, AMD, Intel, Dell, and HPE to ensure compatibility and accelerate adoption of next-generation cooling platforms. Next-generation cooling architectures focus on combining liquid cooling with intelligent controls and real-time analytics. These systems allow operators to manage thermal loads efficiently while supporting high-density computing environments.
Looking ahead, how will data center design evolve?
Future facilities will be designed around integrated infrastructure platforms where computing, cooling, power, and digital operations work together. This approach will help operators manage complex workloads more efficiently. Organizations should evaluate cooling strategies early, invest in liquid-ready infrastructure, and adopt intelligent thermal management tools. These steps will help them support growing AI workloads while maintaining efficiency and reliability. Thanks for joining us on Frost & Sullivan's Growth Podcast. For access to our research, competitive benchmarking, and best practice frameworks, head over to frost.com or email hello@frost.com. We'll be back soon with more to help you stay clear-headed and growth-ready.